So I'd like to talk to you about something called geometric sequences. Okay, and here's an example of one. Geometric sequence is a sequence where you have some starting term, whatever it may be, and to get to the next term on the list, you multiply by a certain number. You pick a number to multiply by. We would say I'm going to multiply by 2. So 3 times 2 is 6. Okay, and then to get to the number after that, you multiply by the same number again. So if we multiply by 2 the first time, multiply by 2 again, we get 12. And then we just keep multiplying by 2 to get the next term. So 24, and then 48, and 96, and so forth. And you can realize you can keep doing this for a very long time. Okay. When you write a list of numbers like this that are generated using some rule, that's usually called a sequence. Okay. If you decide you want to add them all together, that's called a series. Okay, so the word series refers to the sum of a sequence. Okay, just a definition for you to know. All right, let's see if we can make some general statements. Here we go. For example, so suppose I just started with a number a, right? And if it's going to be a geometric sequence, I'm going to multiply this number by a by some number. So I'm going to call the number I multiply by r. Okay. So the next number on the list in my sequence would be a times r, right? Now, if it's going to be geometric, I should multiply by r again to get the next term. So the next term is really the previous term, ar, times another r, times r again, right? So we can write that in more compact form. We can write ar squared. And this next term would be ar squared, the previous term, times another r, or ar cubed, comma, and then you have ar to the 4th, comma, and then you just keep on going. Okay? At some point, you land on the 11th term. So here's sort of a fun question to think about. What would the 11th term look like? It's going to be a times r to some power. What's the power? So this 11th term is ar to the 10th. All right, and then we kept on going. At some point, we land on a term that I'm going to call the nth term. It's going to be a times r to a power to the n minus 1. Okay, so this thing here, what we can say is, this is the formula for the nth term. We can write that this way: a sub n equals ar to the n minus 1. Okay? Let's talk about the series that goes with this. Oh, that's not a big deal. Series just means the sum of the sequence. So the sum of the first n terms, that's what I'm going to call this. I'm going to call this the nth partial sum. That's what this terminology means. So S sub n means add the sum of the first n terms. It's going to look like this. You're going to have the first term a, plus the term that came after it, ar, plus the term that came after that, ar squared, plus ar cubed, plus all the way up to, and we know that the nth term, we just said that a moment ago, is ar to the n minus 1. Okay? So what I'd like to do is get a formula for adding this where I wouldn't have to do the following. So, for example, if I said find S117, that would mean I have to do A plus AR squared plus all the way up to AR to the 116th power. Well, it's going to take a long time to figure out all those numbers and then type them in and add them up somehow. So I'd like to get a formula for this where I could just plug in a few numbers and have an answer. That's going to be our goal. It's actually not that bad. All right, so let's go to a new page and start over. Here we go. So Sn equals A plus AR squared plus all the way up to AR to the n minus 1. Okay, so I'm going to do a trick here for a minute, and you might not know why I'm doing it, but then you'll see something very nice happen. I'm going to take this whole list of numbers in this in this sequence, in this series, and I'm going to multiply it by r. And if I multiply by r, watch what happens. I multiply on the left by r, I get r times Sn. On the left, r times a is Ra. Sorry, on the right that is. And I multiply this next term by r, that guy, and it becomes ar squared. And this term becomes ar cubed plus. And if we give it a little bit of thought, this last term, right, we can tell every power went up by 1. Well, if we start at n minus 1 and we go up by 1, we just land on n. So it's going to be ar to the n. Okay? And just for fun, think for a minute, what term was right before that? Let's think about that. What was right here? ar to the... So this would need to have been an n minus 1. Okay. So again, you might think, I'm not so sure why you did that. Well, watch this. Now I'm going to subtract. And if I do that, if I do this in a clever way, things are going to work out for me. So on the left, you're going to notice Sn minus Rsn. And on the right, I'm going to subtract very carefully. I could try and subtract these, but I don't know how to do that, really. I do, but it's not really convenient. So instead, what I'm going to do is I'm going to subtract these. Cancel. Cancel. There's an ar cubed up here somewhere to cancel. These will cancel. And the only thing left is this on the bottom and this on the top. So the thing on the right becomes a minus ar to the n. And you can see now the advantage of multiplying through by r. I got rid of all those terms that were in the middle, a whole bunch of them. And I'm done, basically. Watch what I do here. On the left, I'm going to factor out Sn. I'm going to have 1 minus r. On the right, I'm going to factor out a. I'm going to have 1 minus r to the n. And I'm going to divide. So the nth partial sum is the first term times 1 minus r to the n over 1 minus r. Turns out to be a pretty handy formula. That's the sum of the first n terms of a geometric sequence.